Okay. In this problems, we're going to be doing the synthesis of these compounds starting from cyclopentanone. So, and here what I have highlighted is one more carbon that I need to add if I start from cyclopentanone. So one way in which we can add carbons to the chain is using the Grignard reaction. So I'm going to start backwards. So I'm going to redraw cyclopentanone. And how do I add one carbon? So I'm going to do metal magnesium bromide, which is your Grignard reagent. So plus negative. So let's do the now a nucleophilic attack over here. So I just cross that arrow. So now, then we're going to be having, hold on. Now I have added the methyl group that I want, and I also have, this is an alkoxide. But so because of that, I want to add a step in which we're going to be adding acid. So as I add the acid, I am going to protonate this alcohol. Here we go. We have it. So see what's the difference between this molecule and that? So we need an elimination reaction. One way we can, this is actually a dehydration of an alcohol. So what we can do, if we use, say, sulfuric acid, and this is used to promote dehydration of alcohol. So we know that OH is a bad leaving group, but once I have, let's see, this is concentrated, and that's heat. When I do that, I am going to have to move that molecule over it, so I'm going to have to protonate the alcohol. Again, remember, we need to do this because OH is a bad leaving group. And so now I have this, and I will form, once this supported, this is the E1 pathway. So we're going to be forming a carbocation that's actually tertiary. That's my intermediate and the E1 mechanism. And now because this is strong acidic conditions, the base that is going to be acting here to remove a beta hydrogen is water. Again, this is your E1 mechanism. We're going to get that and form that double bond. So here we have the compound we wanted to synthesize. Let me remove that E1 from there. So here. So now you have, first step was adding a carbon that I needed to add. So I used Grignard. So metal magnesium bromide, I added that, I formed an alkoxide, therefore I need an acid work cap to protonate that, so that's my alcohol. And the next step is a dehydration of an alcohol. This is a tertiary alcohol. OH is a bad leaving group, so we're going to be using strong acidic conditions. We're going to be protonating that. And this is the E1 path, so water is now a good leaving group, will depart and form a carbocation. This is more stable. And now removing a beta hydrogen with the base that you have available, which is water. So now that's the path to synthesize the first one. And I'm going to, without showing the mechanism, simply I am going to leave just this arrow. We know that this step is to conduct an E1. And here we are. Now, the second molecule that we have here, again, we have a carbon, an extra carbon, and that's an alkene, so I added a CH2. So typically when you have ketone or an aldehyde and you want to transform that into an alkene, we're going to be using the Wittig reaction. So now again, starting from cyclopentanone, the fragment that I need to be using, the elide, will be, well, first let's do it drawing like the form, the resonance structure that is like this, so that you can see clearly what is that you're adding. So you're replacing this with this. Now the thing is how you make the elide. Remember that this is the resonance structure of, you will do here, PH3 phenyl, this is triphenyl phosphine, and this is going to be CH2, negative charge. This is positive. So that's the resonance structure right here. And we know that we can do that because phosphorus belongs to the third period in the periodic table, so we can expand the octet. So this is a fragment. This is your elide in the Wittig. That's the Wittig reaction, what we're doing. But the thing, what I'm doing here is, how do we make the elide? So straight here, this is what we're going to get from the Wittig. But how do we make the Wittig? So if I want to go here, when you're synthesizing the Wittig, you need to start with an alkyl halide and say that it use metal bromide. Then you're going to be doing with triphenyl phosphine, triphenyl. So 3 phenyl groups, triphenyl phosphine, doing an SN2 attack here. You will form the following. So you're going to have this. I'm going to write it on the other side. And now notice this has a positive charge. To form the elide, I need to use a strong base, and typically what we use is butyl lithium. So 1, 2, 3, 4. That is a very, very strong base. So butyl lithium. Again, the pathway here is very simple. Adding 1 carbon here and making an alkene come from a Wittig reaction. But how do I make the Wittig? So you need to analyze what is that you're adding in place of the O. Here you're adding a CH2. So you're starting from this simple alkyl halide, so metal bromide. This is an SN2 reaction followed by the treatment with a very strong base to form that elide. So here you have the second molecule. All right, so I am going to erase this, just keeping in mind that for the second molecule, what we're doing is a Wittig, but all the steps that we explained is to how do we make that elide. Now for the last molecule, did I copy that? I'm missing something. Yeah, that's what I want to make. Okay, so what is this here? I'm adding another carbon, but notice this is a carboxylic acid. Since we have an OH here, that can come from a nucleophilic attack over to the cyclopentanone, but I need to use a nucleophile, and this time so that I can add 1 carbon and convert that into a carboxylic acid. So this time we're going to be starting again from cyclopentanone, as it is in all this problem, and now we're going to be using potassium cyanide, and this is with HCl, the condition. Your nucleophile here, let's put here a positive and a negative. The cyanide anion is like this. So your nucleophile is a carbon atom, so going to be attacking over here. And when you do that, you're going to form, after you protonate, you're going to form a cyanohydrine. And then the cyanohydrine, what we need to do is hydrolyze the nitrile. And that's done. I said the condition, let's do the hydrolysis, and we get that. So notice we have different strategies in which we had added carbon atoms to the initial molecule. Here we have 5. In the first molecule, we have 6 carbon. That one that we added was done using Grignard as my strategy to add carbons to the chain. And we use Grignard, made an alcohol, tertiary alcohol, and then we did an elimination, any one. Second strategy involves transforming cyclopentanone into an alkene, and that's done using Wittig, so another strategy to add carbons to the chain. Lastly, when you see a carboxylic acid, here you're adding another carbon, but a carboxylic acid can be formed easily from the hydrolysis of a nitro. So here we have 3 strategies to add carbons to the chain, change the skeleton of the molecule.